Algebra 4, logs and indices. Indices type 3, exponential equations. So in these questions, what we're going to be asked to do is solve for x. And really what we have is a quadratic equation in disguise. So if we look at this question here, what we should see is that we have this hint in the middle term where we have this 2x in brackets. So if I rewrite that equation so it's all in terms of 2 to the power of x, well, the first term can be written as 2 to the power of x squared, because that would be the same as saying 2 to the power of x times 2, which is 2 to the power of 2x. So in other words, I'm just taking that 2 to the power of 2x term and I'm writing it as 2 to the x in brackets times 2. Then I have minus 6 times 2 to the x plus 8 equals 0. So it should start to look a little bit like quadratic because we have something squared minus a number times a variable plus a constant. So let's see if I change that 2 to the x by letting y equal 2 to the x. Now I can take any letter, but I'm going to take y so that it is a different letter to the one that I'm trying to find. I could use A, I could use B, I could use anything, but do not use the same letter. In other words, don't let 2 to the power of x equal x, because that will only make it very, very confusing for you. Choose a different letter. So wherever there's a 2 to the x, I'm now going to write y. So that equation is now going to become y squared minus 6 times y plus 8 equals 0. So in other words, whatever was in the bracket, 2 to the x, is now going to be replaced with y, which gives me y squared minus 6y plus 8 equals 0. So now this becomes a very easy quadratic to solve. So in other words, I'm going to say, well, if I take that equation, y squared minus 6y plus 8 equals 0. Well, what multiplies to give me 8 and adds to give me minus 6? Well, that must be minus 4 and minus 2. So if I replace minus 6y with those two values, I have minus 4y minus 2y plus 8 equals 0. Taking out the first two and the second two and grouping them and taking out the highest common factor. Well, y is common, leaving me with y minus 4. Minus 2 is common, leaving me with y minus 4. And now again, I can see these two brackets are the same. So again, if I take out the highest common factor, I have y minus 4 times y minus 2 equals 0. So if I let both those factors equal to 0, well, that allows me to solve for y. So I get two values, y equals 4 and y equals 2. However, I wasn't asked to solve for y, I was asked to solve for x. And I know that y is equal to 2 to the power of x, because that's what we let it equal to at the start. So now I say, instead of saying y equals 4, I say 2 to the x must equal 4. And instead of saying y equals 2, I must say 2 to the power of x equals 2. And now we're back to what we were doing yesterday. I can say, well, 4 can be written as 2 to the power of 2. And because the bases are the same, I can equate the powers, which gives me x equals 2. And if I do the same for the second equation there, I have 2 to the x equals 2. So remember, 2 is the same as saying 2 to the power of 1. So because the bases are the same and I have a single term on the left and a single term on the right, again, I equate the powers because the powers must be the same. And I get my second value for x. It must be x equals 1. Okay, so let's have a look at a second example. Okay, so here we have a little bit more work to do. Again, the middle term is always my hint. This is what I'm going to let y equal to. I'm going to let y equal 3 to the x. But of course, I must write this first term as 3 to the x raised to some sort of a power. So of course, I know from my indice rules that I can break this 3 to the power of 2x plus 1 into 3 to the power of 2x times 3 to the power of 1. because if we go to page 21 in our tables, we can see this first rule up here. So a to the p times a to the q is a to the p plus q. So all I've done is I've gone from right to left there by taking the 2x plus 1 and writing it in the form of a to the p times a to the q. In other words, 3 to the 2x by 3 to the 1. And then I have minus 4 times 3 to the x plus 1 equals 0. So again, I'm just going to take this first one because I want to write it as 3 to the x. So of course that can be written as 3 to the power of x squared times 3 minus 4 times 3 to the x plus 1 equals 0. Because again, if I look at this third rule down here, if I have a to the pq, then that can be written as a to the p brackets to the power of q. So now what I'm going to do is I'm going to say let y equal 3 to the x, and therefore wherever there's a 3 to the x, I'm going to put y. So that gives me y squared times 3, so that's going to be 3y squared, minus 4 times y plus 1 equals 0. And now again I have a quadratic. So I'm going to say, well, 3 times 1 is 3. So what are the factors of 3 that add to give me minus 4? So it must be minus 3 and minus 1. So if I replace minus 4y with those two factors, I have 3y squared minus 3y minus y plus 1 equals 0. Taking out the highest common factor there, between the first two and the second two, I have 3y, which leaves me with y minus 1. Minus 1 is common, which leaves me with y minus 1. And again, these two brackets are the same, so I take them out as the highest common factor, which is y minus 1 times 3y minus 1 equals 0. So that means that both of those values multiply to give me 0, so one of them has to be 0 or the other has to be 0. So by letting y minus 1 equals 0, I get y equals 1. And by letting 3y minus 1 equals 0, I get 3y equals 1, which gives me y equals 1 divided by 3. So I have a third. But again, I was not asked for what is the value of y. I was asked to solve for x. So I need to remember that I let y equal x. So I say, but y is equal to 3 to the power of x. So that means that 3 to the power of x must equal the first value of y, which was 1, or 3 to the power of x is equal to the second value of y, which was a third. And again, I know I have to write both of them to the same base. So in other words, 3 to the x must equal 3 to what power? Well, if the number is 1, then I know the power has to be 0, because anything to the power of 0 is 1. So now that the bases are the same and I have a single term on the left and a single term on the right, I can equate the powers, which means that x must equal 0. The second one, I have 3x equals 1/3. So again, I have to write it as 3 to a power. So a third is 3 to the power of minus 1. Because again, if I go back to my rules on page 21 of my maths tables, I can see the rule here where I have 1 over a to the p is equal to a to the minus p. So if I have 1 over 3, well, that's the same as saying 1 over 3 to the power of 1. So p is 1, so I end up with 3 to the minus 1. So again, single term on the left, single term on the right, same basis, so I must equate the powers. They have to be the same. So my second value for x is that it can equal minus 1. Okay, so third and last example. So again, we're going to try and solve for x. So this one's a little bit different here because we have a 2 to the x plus 2 to the 2 minus x equals 5. So first of all, I'm going to bring everything to the left-hand side. So 2 to the x, 2 to the 2 minus x minus 5 equals 0. Again, I can see I have this term here, 2 to the x. So we're going to let that equal our y. But before we do that, we're going to have to take the second term and write it as 2 to the x as well. So I have 2 to the power of 2 minus x. So if I go back to my maths tables, again, this is our first rule up here, where I'm going to take it and break it into two separate terms. In other words, 2 squared times 2 to the power of minus x. So when the bases are the same, we add the powers, which is going back to where we started, to minus x. So I can, of course, use those rules left to right, right to left. But that's still not 2 to the x. It's 2 to the minus x. So we have to remember that 2 to the power of minus x can be written as 1 over 2 to the power of x. Again, going back to our tables, that's this rule here, a to the power of minus p. Okay, so now I can see I have two terms with 2 to the power of x in it. So I'm going to let y equal 2 to the power of x. So if I do that, I can see I'm going to have a y here. So that's going to be y. 2 to the power of 2 is 4. And then I have 1 over 2 to the x. So that's going to be 1 over y minus 5 equals 0. So this time when I've let y equal 2 to the x, it doesn't quite look like a quadratic. I have a fraction, and we always want to get rid of our fractions. So of course, to get rid of my fraction, I must multiply across by the lowest common denominator, which is clearly y. So I multiply every term by y. So y by y is y squared. Y by 4 times 1 over y is going to be just simply 4, because y times 1 over y is 1, because y goes into y once. And then minus 5 times y is minus 5y equals 0. And now, of course, if I rearrange that, I can see I have my quadratic. So I say, well, what multiplies to give me 4? That adds to give me minus 5, the middle term. And it must be minus 4 and minus 1. So I have y squared minus 4y minus y plus 4 equals 0. Grouping the first two and the second two and taking out the highest common factor. Well, I have y times y minus 4 minus 1 times y minus 4 equals 0. And again, I have y minus 4 as common. So if I take that out, I'm left with y minus 1. And then if both of those multiply to give me 0, that means that one of those factors have to be 0 or both have to be 0. So that gives me y equals 4 or y equals 1. But of course, we have to remember to finish the question where you're asked to solve for x. So I go back to the fact that we have said that y was equal to 2 to the power of x. So that means that if y is equal to 4 or y is equal to 1, that 2 to the power of x must equal 4 or 2 to the power of x must equal 1. So to solve, we must have the same base on both sides. So of course, 4 can be written as 2 squared. I have a single term on the left, single term on the right, same base. So I equate the powers and I get x equals 2. And here I have 2 to the x equals 1, but we have to remember that I need to write it as 2 to a power. So of course, 2 to the power of 0 gives me 1. So a single term on the left, single term on the right, same base. So by equating the powers, I get x equals 0. Okay, so what you're going to do now is go to page 181. And I've taken these examples from questions 8, 9 and 10. So you're going to do the questions in 8, 9 and 10 that were not these examples.